Okay, says, so the following diagram shows a hemispherical bowl of radius 15. Some liquid has been poured into the bowl to a height of 8 centimeters with a circular surface radius BC. State the length of AC. Well, AC is a radius for that sphere, right? Because it's the A is the center of the circle at the hemisphere. And anything going from the center of the sphere to a point on the sphere is going to be a radius. So that's 15. Likewise, A to here is going to be 15. So if this piece is 8, that piece must be 7. And then we can just use the Pythagorean theorem to find out BC. And I'll skip that part because I'm sure you're good with that part. Yep. So again, the tricky part was just noticing what was a radius and what wasn't in the problem, right? Ben. Sure. Okay, so 21 says liquid has been poured into a spherical container to a height of h centimeters. The radius of the sphere is 22. The top of the liquid is a circle of 10. Work out the height of the liquid h to calculate the volume and then the surface area. So I know that this is also going to be 22. Because that's a radius. And in addition, I know that this is also 22 because that's a radius. So then I can use the Pythagorean theorem. Why am I doing all this work? We don't need to do any of this work. I just need the volume of the sphere minus what are we trying to do here? Calculate. Why did I give you this information? Calculate the volume of the sphere of the liquid contained in it. Well, I'm not really sure. Let's assume we're looking for the volume of the liquid in there. We don't need any of that stuff to do that. Yeah. And then I would say the surface area is the trickier one. So the surface area of the liquid is going to be the surface area of the sphere minus the surface area for the hemisphere with no base.
What does it mean, like, no base?
Well, like, you have, like, this. Are you counting the bottom of this or not? That's what the base is for the hemispheres, whether you're counting that circle surface or not. But we would have to add in that small circle at the top, right, for the top part of the water there. So the surface area of the sphere is going to give us all of this spot when we minus the hemisphere out, but we still need that surface to add back on at the end. Does that make sense? Okay. And I can't tell from the context of the question. We've clearly written a poorly worded question here. Are we talking about the volume of just the sphere, of the liquid? I'm not even really sure. I'm going to pretend it's the liquid because that's a more difficult question. If it's just the sphere, then you're just plugging crap into a formula and it's not a big deal. Yeah. Abby? Yeah. Okay. We'll talk about that in a minute. What else? Yes, Caroline.
Can you do number 32?
Sure. All right. It says that Nadia designs a waste paper bin made in the shape of an open cylinder with a volume of 8,000 cubic centimeters. Nadia decides to make the radius of the bin 5 centimeters. Do you guys know what it means when it says open cylinder? It's like a garbage can, right? It has no top on it, so you can put your junk in it. Okay, calculate the area of the base. Well, I mean, just pi 5 squared. Calculate the height. Well, I know the volume is pi r squared h. So 8,000 times that. So I just solved that equation to get h. I'm going to leave that for you. Is that okay, Caroline? Okay. And then it says give the total external surface area of the waste paper bin. So there we have the side of it, which is the perimeter of the base, times the height, plus the bottom. And I just left that as h in there because we didn't solve it in the previous problem, but you just plug your answer for part B into that spot. I assume that's okay, right?
Yeah.
Okay. Whether this design is practical or not, time to exit the book world and enter the real world. So 5 centimeters is about 2 inches. So the diameter of this waste paper bin is what, like this big? Does that feel very practical to you? No, for lots of reasons, right? One is that it's hard to fit garbage into it because it's so small. The other piece is I bet it's going to be pretty tall with a little tiny base. That's awfully easy to get knocked over, which is not a feature for a garbage can I would like. So kind of those reasons would be good reasons to say it's a crummy design. You guys buy that? Okay. Marin also designs a cylindrical waste paper bin with a volume of 8,000 cubic centimeters. She decides to fix the radius of the base so that the total external surface area of the bin is minimized. Let the radius of Marin's waste paper bin be r and let its height be h. Write down an equation in terms of h and r using the volume. I know the volume is given to us to be 8,000. And I know that for a cylinder, the volume is just pi r squared h. It says, show that the total external surface area, A, of the bin is given by this equation. Well, I know that my surface area equation is this. Notice that this equation, though, has an h, and the equation that I'm trying to get to doesn't have any h's in it. So what I'm going to do is I'm going to solve that volume equation in terms of h. And then substitute it into this equation so that I don't have any h's. So when I do that, that r cancels that r, that pi cancels that pi, and then 2 times 8,000 is 16,000. And that's exactly what I was trying to get to. So far, so good? Now it says find the value of R that minimizes the total external surface area of the waste paper bin. I'm going to use my calculator to do that. What I'm going to do is I'm going to graph the function that's given to me in part B, that pi r squared plus 16,000 over r. And then I'm going to look for a minimum value there. So to graph this, I know from the previous problem that if r is 5, then the total external surface area was about 3,500. So I'm going to use that as like, well, I know that my surface area can't be worse than that if this is going to actually be the minimum. So I'm going to choose that as like my upper bound for the y. And then I know 5 gives me that probably pretty crummy surface area. So I'm going to pick something like 20, something a bit, something bigger than 5 to be my upper bound for the radius. I'm assuming that like something that's a little bit wider is going to be a better design than something skinnier. But I go from 0 to 20, which if it is smaller, which it's not going to be, I would catch that too. So I'm just going to go ahead and graph this. So this is the curve that I get. So the minimum appears to be right about here. So I'm going to use my calculator to find that exactly by pressing second and then the trace button and choosing the minimum command. This is going to ask me 3 questions. It's going to ask me a left bound. So I'm going to pick a spot that's left of where that lowest spot is. So this looks good. Anywhere left of it is fine. Press enter. Now it's going to ask me a right bound. So I'm going to just pick a spot to the right of that lowest spot. Anywhere right of it, it's fine. This looks good to me. I'll guess. The guess doesn't matter as long as you pick inside of the 2 bounds that you've described. It's fine. So I don't even bother moving it. I'm just going to press enter. So the calculator says that value of x is 13.66 to give me a surface area of 1,757. So 13.66 is the answer there. To get the value of h, I'm just going to go and plug it back in here. And I think that comes out also to be right about 13.6. When I type that in, should be real darn close. And now we ask, is this a better design? Well, so let's think about this. So 13.6 centimeters is about 5 or 6 inches. So you're talking about something that's maybe a foot wide as your waste paper bin, which is not too bad. Unfortunately, it's only like 6 inches deep, but it's going to hold a lot bigger kinds of garbage, and it's going to be much harder to knock over, which I think are definite improvements upon that previous design. Does that feel okay, Caroline?
Yeah, thank you.
You're welcome. Notice on these questions, though, that even if you weren't able to do one part of it, the next part is still doable. Like none of these parts really depended on, directly on the answer from the previous one. And oftentimes the hardest parts were the earlier part where you're asking to show something. Like I had the equation that I needed to graph to find the minimum, already. So I didn't even actually need to do the show part. If I wasn't able to do that, it didn't restrict me from doing the future part. That kind of thing. So most of the time, these multi-part questions are built that way so that, if you can't do some little piece of it, it doesn't restrict you from doing the whole problem. What else? Okay? That's